He's telling me to get a move on. Okay, let's have a quick look at the virtualization stuff.
It's an interruption.
Yep.
We'll have time later today if you want to go into more details. So,
Yep.
Please save your questions on this.
Okay. So this is the high-level diagram of how Sun does virtualization and compartmentalization across everything from, on the far left-hand side here, what we call dynamic system domains, which is hardware-level isolation, also very tightly tied with high fault tolerance, redundancy type concepts. We've done a number of different systems in that area. Multiple OSs, different patch levels of Solaris. Then you've got the kind of hypervisor layer, next one up, multiple different operating systems, all running on the same architecture, many different ways of doing the hypervisor. And then the trend towards things at the other end, which are, as we come through zones, are more into the resource management. All of these have a different security impact in terms of how complex it is to deploy them, to what policy it is you're trying to get, and what type of isolation you need between the applications or the operating systems themselves. So let's focus a little bit on the OS virtualization layer for zones. So zones is the Solaris 10 technology that provides virtualized application environments. It's not multiple different operating systems per se, because there's only one kernel running. What we have done, though, is provide a way that you can give the illusion of a full user land to as many different applications as you like. We even have zones that can appear to be a user land instantiation of Linux, or just very recently integrated a user land Solaris 8, 9, or 10 sitting on top of Open Solaris. So the kernel is Open Solaris. You get all the nice benefits of the new ZFS features, new privilege features, everything on the kernel side, but your user land looks like Solaris 10, or even back as far as vintage Solaris I. Each zone has its own security boundary around about them, and because things like the name service, concepts of passwords, everything are all completely user land concepts in Unix, every zone has its own root account, its own root password, and all the damage that they can do is to their own zone. And the way we get that is this is highly integrated with privileges. We could not have implemented zones had we not done privileges first in the way that zones work today. The goal is that zones are isolated from each other in the default configuration and can only communicate with each other if they can reach each other out over the network. There are two very different ways of configuring the networking. At a high level, we share the IP stack, or every zone get its own IP stack. And depending on what your policy is, one may be a better choice for you than the other. There are different security trade-offs between shared stack and exclusive stack IP. And zones, to give them this level of isolation and to ensure they can't tamper with each other or tamper with core hardware functionality, run with fewer privileges. And there are some privileges that zones can never be allowed to have. So why do we want to run your services in zones? Well, it's a good way of doing consolidation, consolidating two different servers with different security policies that deal with the similar classification of data. You can run them on the same system. You're getting the advantages of virtualization there, but you get a strong security protection between them. You can also apply resource controls to your zones, so you can protect against denial of service attacks on the CPU, memory, disk, because you can quota these things, both from the global zone, which is what we call the Solaris kernel in the default environment, and also within the zones themselves. So you can delegate 10% of the CPU to zone A, and then within zone A, the administrators of that zone can then break up that 10% they have in further down into other fragments as well. You can observe what's going on inside the zone in two different ways, either by auditing and looking at its file system state from outside the zone or from inside it. And I'll cover a little bit more on auditing later. Going to be a lot more on the virtualization and how we use it to build trusted extensions in some of the later talks, so just a quick highlight on that one. On the crypto side, it used to be that adding crypto to products originating in the US was very difficult. Around about the time we were developing Solaris 10, the laws changed in our favor that allowed us to introduce a generic encryption framework that could be used by anything in the kernel, anything in user land. And the idea was that since we were given this new flexibility, we wanted to get down to as few implementations of the encryption algorithms as possible, because that means that we can optimize them for a given CPU, given piece of hardware that might have some additional support, and make them available to as many of the standard crypto APIs as we could. Things like PKCS11, OpenSSL, the encryption layer in Java, the JCA. But we also wanted to make it pluggable, because encryption doesn't stand still. You know, when we first started developing the architecture for this, the state of the art was triple DES. AES was not chosen at that point. We knew it was coming. Even now, there are attacks against AES in some modes and in some key lengths. It won't be with us forever. But as far as the way the applications use the crypto, it hasn't changed that much. It's still very much, here's a block of data, here's a key, some extra stuff, give me the encrypted version back. And it's easy enough to abstract that layer and make it pluggable. The other reason for making it pluggable is, in some environments, there may be algorithms that we don't wish to ship as standard part of Solaris that the end customer wants to use. Our initial use case for this was some special government algorithms that certain government agencies wouldn't give us access to, but they wanted to run on an otherwise general purpose operating system. But we are also finding that in different geographies in the world, some algorithms are more popular than others. And they may not be popular enough for us to include them in Solaris and take on the burden of support initially, or we may want to be pioneers and start adding additional algorithms because we think they're going to become popular. For example, we could, if we wanted to now, add all the SHA-3 contenders and make them all visible under the default names if we had the resources to be able to do that and we thought it was worthwhile. We'll probably wait a little bit longer, maybe at least to the end of the next round before we start adding these in. And the idea was everybody that needs crypto in the operating system should use it. And by and large, we've succeeded in these goals. We add new features to this on an ongoing basis. For example, when the UltraSPARC T2 processor came out, it has on-chip encryption capability for AES, for the SHA-2 suite of algorithms, as well as RSI. We added elliptic curve stuff. We very recently integrated the code that allows us to operate in a FIPS 140 mode. We haven't completed the FIPS 140 evaluation, but we now believe that we could do so. Another recent addition was the Intel Core i7, the Nehalem processors, have the ability to do AES on chip using a new set of instructions, and that code is in Open Solaris as well now. There's also a policy interface in here because as crypto algorithms date, we want to be able to encourage people to move away from them. And in fact, sometimes government agencies set out policies of, thou shalt not use DES after this date. So how do you stop the applications using it? Well, if the applications are using the encryption framework, the administrator can say, disable DES. It's gone. Or disable this version of DES. So triple DES is okay, but single DES is not. And if the applications ask the encryption framework to use it, they'll be told, sorry, it doesn't exist. And they'll have to go and do something else. This also allows us to transparently switch between software and hardware providers, because as we designed the policy system in the framework, you have to be able to deal with things not being available. We can load balance across multiple different hardware providers. For example, the UltraSPARC T2 chip actually has multiple different crypto cores on it, and we can load balance across those to get the best possible throughput. The work that we're doing just now in the encryption framework is starting, because of things like the Intel Core i7 processor, the world is changing from being a software encryption slow, hardware encryption fast, because what's software and what's hardware when your general purpose processor has an instruction in it to do an AES round? So the world's changing. We have to adapt a few things in the framework, but by and large, the original architecture stands. As an example of how fast the UltraSPARC T2 processor is when used through the encryption framework, the slide didn't render very well. Comparing it to a general purpose quad-core Opteron or Cloverton processor, you can see it is significantly faster on RSI. And again, significantly faster on AES. these are peak output on an otherwise idle system where the goal was to maximize crypto throughput. In the real world, you're probably running some real application on your processor. Yeah, I didn't misplace the decimal point. It really is that much faster. Now, I need to do an update of this slide now that Intel Core i7's come out and fit that. It will fit in somewhere in between. Where this makes a big difference really is in SSL processing, particularly when you combine it with the in-kernel SSL accelerator that we have in Solaris. Because you can ensure that we do the crypto as close to the chip as we possibly can without having to send it all the way up into user land to do the expensive RSA operations. Okay. So, as part of providing a pluggable encryption framework, while I said that the US export laws changed very much in our favor, there is one that is still a requirement, is that we're not allowed to produce a fully pluggable system that anybody anywhere in the world can plug in some random crypto algorithm. We have to kind of make it a little bit difficult for them. And this is called crypto with a hole or open cryptographic interface. And as part of doing that, we provide a means where you could actually cryptographically sign the binaries. And all crypto modules must be signed by a cert issued by Sun. We don't see your binaries, we just issue you a cert after checking you're allowed by the US government to get one. It's not a very onerous process. In doing so, we also actually went and signed all of the binaries in Solaris, but the only ones that we automatically verify are ones plugged into the crypto framework. This is a precursor to the validated execution project. At the moment, most of what you can do with it is say, is this copy of SSHD or LS actually the one that's supposed to be on this operating system? Is it a way of detecting whether you've got a Trojan horse or not? It's a little bit different to doing it with something like Tripwire or BART, because here you can say, yes, this binary actually was one issued by Sun. It still doesn't tell you if it's the one that should be on there. So you want to still use something like the Fingerprint database, which is hosted on SunSolve, because this will tell you this is a good copy of LS. It hasn't been modified since Sun shipped it, but it could be a buggy one that you don't want to use. So it's another layer. It's another opportunity for you to be able to have a look at this. This only applies to ELF binaries, and the validated execution project wants to apply to much more, so it's going to have to use some different techniques. So going back to the talk from this morning, yes, we've implemented all these horrible checks that this morning's talk now said maybe weren't such a good idea. We allow you to create your password complexity checks that will frustrate any user. Combine that with so we now have the ability to do password history with 52 entries in the password. You could tell the user they have to change their password every 5 days. They can't use anything in the last history. Put all the complexity rules in. And then we will hash the password with a stronger hash algorithm as well. Use it with care. It really will only frustrate your users. The most important part here, I think the one that we did, was switching away from the Unix hash algorithm. We actually did that change in update 2 of Solaris 9. And more recently added support for a SHA-256 and SHA-512 based password hash. With the exception of the Sun MD5 ones, all of these are compatible with what you'll find on BSD and Linux in terms of the actual hashes. The way that we did it differently was that we actually made the crypt function itself pluggable so that we can add these without having to go back and modify the source code of any of the applications or any of the other parts of the OS. So our PAM modules don't have to be modified or anything else. And I think Willis can attest to that, since he added the SHA-256 and 512, and all he did was deliver 2 new binaries and an update to a config file.
So am I reading this slide correctly? You have a PAM module for doing password complexity testing, as well as password history?
Yes. Yep. They come in some update release of Solaris 10. I don't remember which one. Most of it was probably there in the first release. The password complexity checks are all configured locally in the etc default password file, and it's all implemented in the PAM auth talk check module. Password history is there as well. And we also have account lockout. In Bill's talk this morning, he mentioned PAM tally. I had a version of PAM tally implemented about 2 years before PAM tally existed in the open world, but we never shipped it because I didn't like the architecture, and other people involved with PAM agreed. Doing that inside the module wasn't the right way to do it as a separate module, because it actually only applies to a given account type repository. So how you do account lockout for Kerberos is very different to how you do it to traditional Unix username and password. So we actually implement account lockout inside our Unix module. So you won't find a separate account lockout module that you stick random place in the stack on Solaris. So it's integrated into our existing Unix ones. So all of this is there. Most of it's documented in the password man page or various things there. But by and large, just turn it all off.
Question on the pluggable crypt.
Yep.
Do those forms actually work with LDAP?
Yes, they do. But it depends on how you're using LDAP. So there's two different ways of using LDAP. Thus, there's two different. So if you're using LDAP as a name service to satisfy your get X by Y stuff, then you've got a choice when you use LDAP for authentication is, are you using LDAP basically as it's the old NIS stuff running over the LDAP protocol, in which case the client machine does a get PWNAM, grabs the encrypted, the hashed password, hashes what the user typed in and does a string compare. That one works perfectly well, because all you're doing is storing a different shaped piece of data in the LDAP server. If, on the other hand, you have the PAM LDAP module in your stack, what you're actually doing is an LDAP bind, probably over SSL, maybe SSL with SASL, with GSS API, with Kerberos stuck underneath it. We support that configuration. So it really depends. And in that case, it depends what your LDAP server is. If your LDAP server, when it hashes a password and it does that compare for when it's saying, satisfying that LDAP bind, if it uses the underlying Unix crypt, then what you'll find stored in the name service is probably something like curly brace, crypt, curly brace, and then this big SHA-256 hash-based thing. So it depends on your LDAP server when you're running in the LDAP bind configuration, whether or not this works or not. We know it works with the Sun LDAP server. I believe it works with Open LDAP as well. LDAP it's their name service, but it's also an account authority, and it depends on how you actually do the authentication to it, whether or not this is the right way to do it. Because on the other hand, if you're doing LDAP bind, you probably don't even care about Unix passwords because you might have a Kerberos ticket underneath there. And now comes the laundry list of stuff. Solaris Audit has been around a very long time, at least 14, 15 years. Longer? Yeah. 20 years, wow. And by and large, it hasn't changed a huge amount because it did pretty much everything it needed to do. One of the most recent set of changes that we did, though, were with the introduction of zones, you had to be able to record in the audit trail what zone was doing things. And we also introduced the ability to view the audit trail in everyone's favorite format du jour as XML. The nice thing about being able to put this in XML is it allows you to build much more easily tools to analyze the audit trail, because it's something we're still not particularly great at doing, is providing analysis tools for this. And if we can get this out in XML, it's often easier to drag it into other systems. So this ties very nicely into RBAC and roles, into zones, because now you know in the audit trail, it was user Joe in a particular zone, he had SU'd to root, and he run this command with privilege. You get a lot of very detailed information, so it's much more difficult for users to hide from you. How you deal with auditing in zones depends on what policy you want. When you're running trusted extensions, or you're running in some modes where what you're doing is providing isolation between the zones from a security point of view, chances are you want to run auditing outside of the zone. The zone's administrators themselves don't get to set what's audited. That's done by somebody else. So they don't even know they're being audited in many cases. So, or you can choose to delegate the administration of audit down into the individual zones. The other thing that we recently added that I didn't put on this slide is that we now have a way of exporting the audit trail off the system in a secure way. So you can stream the audit trail off using a Kerberos protected transport off to another system to be received as an audit trail there. So the idea is that you get the audit records off the system live and they're off into another system without having to depend on NFS, without having to depend on SSH or anything else. It's a plugin for audit day. Open Solaris only at this point.
Only in Open Solaris?
Yep.
What's the name of it?
It's called Audit Remote is the man page you want to look at. Yeah, Audit _ Remote. It's just a plugin for Audit Day because we made Audit Day pluggable in Solaris 10 so that we could start adding things like this.
When did that put that? Because I thought that wasn't integrated yet.
The client side is integrated, the server side hasn't. The reason we could integrate the client side without the server side is we have a third party who is writing a server at the moment. The server side's coming only a few builds ago. Yeah, and literally only a couple of builds ago. I don't think it was in 2010 or 06. Basic audit and report tool. This is audit in the sense of has it changed, not as in the sense of Solaris Audit. It's tripwire, basically. This is getting enhanced as part of the validated execution project to do many more things, including XML type output as well. Solaris Fingerprint database, it's a service that runs on Sunsolve. The idea is you take an MD5 digest of the file, put it into a web page on the Fingerprint database, and it will tell you exactly where that binary came from. So you will know whether or not this is a genuine binary from Sun and exactly which patch version it came from. We do this for every Solaris version still supported, many that are long since no longer supported, and a bunch of layered Sun products as well. Why is it MD5? Is because the database is huge, it's been generated, and it's a massive amount of work to go back and regenerate all these hashes for very little benefit, given what the nature of this is. The idea is not here to use the best possible hash. It's a way of providing you with some assurance that this SSHD binary was actually one that came from a Sun patch. Chances of getting collisions, even though MD5 is considered weak, it's not worth us going back and regenerating the database at this time. We may do so in the future.
So, is the database itself accessible?
The database itself is hosted by Sun. Okay. It's our IP, we host it, and we provide a service on the sunsolve.sun.com site where you can connect to that, and you give it a bunch of hashes, and it will give you back output that looks like this. It says, this is where the file should be installed, this is what package it came from, it's for this architecture and stuff like that. So we don't ship the database out.
And it's not something that we can implement locally?
No. You could do a similar thing using BART. The advantage of what the database provides is that we know exactly which patch revisions and everything these binaries came from. You could reverse engineer all this data if you trawled Sunsolve and downloaded every single patch we've ever released, because that's basically how it works. But we don't actually release the database itself.
No, I was mostly interested in whether or not it could be used for system integrity checking beyond the operating system.
Yeah.
For the applications and...
Yeah. That's more what the BART program is designed to use for. So it will give you reports that say, this is where this file was, it with these permissions, this is what its MD5 hash is. So if you look at the BART program for that. I'll skip over the ZFS one, come to the ZFS crypto talk this afternoon. But in terms of data security that's nothing to do with crypto that ZFS provides, it has a different access control list mechanism to what UFS had. UFS implemented the failed POSIX draft method of doing ACLs, which are very hard for people to get their heads around sometimes. Instead, we use the same style of ACLs as NFS v4, which is also the same style of ACLs that NTFS has. All the data is authenticated with cryptographically strong checksums. We have file system snapshots, quotas, and reservations to help you protect against denial of service. And there is a huge laundry list of other, where we are.
What was the one on Kerberos?
Kerberos is one, where are we? It's really just a bunch of additional things that we've added over since we first released Solaris 10. Mostly to do with interop support with Active Directory, keeping up with the latest Kerberos drafts and stuff like that. So I am out of time. Are there any quick questions before?
Last slide. How you doing on TPM stuff?
Will is sitting over there, is our expert on TPM stuff. He's recently integrated support so that we can take ownership of the TPM. We've got the low-level drivers. You can use it via the PKCS11 APIs. Basically, it's a very slow encryption device and key store device at this point. The validated execution project has an intent to use the TPM for more stuff and actually use it to do attestation as the system boots up through the bug. Are we doing anything on remote attestation at all?
Not yet. We also have the TSS APIs, so you can program your own TPM applications, but we haven't done any attestation protocol.
Cool, thanks. And I see a TSP reference up there. A question about that. Last time I checked, RBAC bond, for instance, was not wrapped.
It is.
It is now?
Yeah.
Okay. Assuming that there's still something that's not, is the recommendation for things that you can't control using some rules-based authentication, authorization, just use IPF for that?
If it runs out of inetd, inetd will automatically wrap it for you. If you can't run it out of inetd and you can't modify it and it doesn't use it, then use IP filter. But you may also be able to use the new IP filter capability that's built straight into SMF so that the rules are held with there. Have I got time for one last one, Chris?
Yeah.
There was another one over there at the back.
Just wanted to ask really quickly as far as Solaris Audit, you know what the status is?
It's an open Solaris project being developed in the open. There has been some recent integrations to use some features, but the project name is SST, and it's on the Open Solaris website. So we open sourced it all, and yeah, go and contribute that way, feed in your features that way, and if you can, yeah, bug fixes, new features for it as well. It's still by and large the code base is targeted towards running on a Solaris 10 or earlier system. There's going to have to be some work to bring, if it's going to be brought into work on Open Solaris, that work has to be done, and we want the community to help us do that, because by and large we're trying to get away from the need for it by changing other things in Solaris. But it's there, it's part of Open Solaris now. Was there another hand up somewhere, or did I catch them all now? Okay.
All right, thank you.
Done. Thank you.